Okay, this is about the AQA electrolysis required practical, and you have aqueous solutions of these four compounds. You've got sodium chloride, they're all aqueous, sodium sulfate, copper chloride, which is kind of a bluish color, and copper sulfate, again that's bluish due to the presence of the copper 2+ ion. What do you do is, right, so you see what comes at each electrode. Now this this little blue thing here is supposed to be a bit of blue litmus paper. You can actually use pink as well, it doesn't matter, but blue litmus. And it's a test for chlorine. And if you're producing chlorine gas there, it will bleach the color. Okay, so with sodium chloride, what happens is, yeah, you do get the color gets bleached there. So you lose the blue color because the chlorine is produced at the positive electrode, and at the negative electrode, you see lots of little bubbles, and those bubbles are of hydrogen. Okay. Now, when you do it with sodium sulfate, again, the negative electrode is the same. You see bubbles of hydrogen being produced at the negative electrode, but you don't get any bleaching at the positive electrode. The litmus paper, that stays blue, but you do see little bubbles there, and those bubbles are of oxygen. In the practical thing, it says you could collect the oxygen, but it'd take a long time, and you could do a test for it, relights a glowing splint. But in the instructions, they say if it's not chlorine, you just presume it's oxygen. So that's oxygen there. Now, when you do the copper chloride solution at the negative electrode, you I just different color. If you do copper chloride, what you see happening is you don't see any hydrogen gas being produced at the negative electrode, and that's because you're getting copper, that red color there, you're getting copper metal deposited at the electrode. At the negative electrode, you get bleaching of the litmus paper, it loses its blue color, and that's because you are producing, at the positive electrode, you're producing chlorine. At the copper sulfate, well, you see copper being deposited at the negative electrode, and you don't get any bleaching of the litmus paper, but you do see little bubbles being produced at the positive electrode, and those little bubbles are of oxygen gas. So just to summarize that in a little table here, and then we'll explain what's going on. Okay, so whenever you have sodium at the negative electrode, you don't get sodium produced there, you get hydrogen gas. And that's because sodium is reactive. So you get H2 gas, you get H2 gas. Whenever you have a copper solution, yeah, you are going to get copper metal being produced there. And the copper sulfate, you get copper metal again. And if you electrolyze it for long enough, you'd notice the blue color of the solution due to the Cu2+ ion, that would fade. At the positive electrode, whenever you have chlorine there, you always get, when you've got a chloride, so sodium chloride or copper chloride, you get chlorine gas produced. But when you've got sulfate, you don't get anything to do with sulfur, you get oxygen gas being produced. Okay, so let's explain that. Now, where does the hydrogen, in the cases where you produce hydrogen, and the cases where you produce oxygen, where are they coming from? They're actually coming from not the salt dissolved in, but the water itself. Okay, so I'm going to write down the reaction here. Water, we said before in previous videos, a very small proportion of water is always split up into ions. It's a reversible reaction. So you get small amounts of H+ ions and H- ions. It's about 1 in 10 million. 1 in 10 million molecules of water will split up 10 to the 7, and that's an equilibrium reaction. Okay, so whenever you've got, let's see, whenever you've got the negative electrode, let's talk about that first of all. The negative electrode, you're always going to have sodium ions all right? Or if they're not sodium ions, it would be copper 2+ ions. But you've always got, in each case, you've got H+ ions from the water. Okay. Now, if you've got copper, it's all to do with the reactivity series of metals. So if you remember the reactivity, the order, sodium is obviously the most reactive, then hydrogen is the next reactive, and the least reactive is copper. And the rule is that if the metal is more reactive than hydrogen, you don't get the metal released at the negative electrode, you get hydrogen gas. So it's more reactive than hydrogen. And of course, copper is less reactive than hydrogen, sodium is more reactive. So that explains what in the sodium, when you've got sodium, you are not, the sodium ions will not accept an electron because they're too reactive. Instead, the water accepts the H+ from the water, that accepts the electron. So in the case of the two sodium solutions, sodium sulfate, what happens is you get H+ from the water, gain an electron, and it'll turn into hydrogen atoms. And of course, two will join together to form hydrogen gas, just balancing that there. And of course, what that means is that when you do this, because you keep removing these hydrogens, more and more water will keep splitting up to replace those hydrogens. And so the amount of hydroxide ions will increase. So the OH- ion concentration will increase and it will become alkaline. Okay, but the copper, much more straightforward. The copper isn't very reactive, so it's quite happy to accept 2 electrons from the negative electrode and it will form copper metal. Let's see what happens at the positive electrode. Now, when you've got, so then the ions we need to worry about, we've got chloride ions in the 2 chloride solutions, we've got sulfate ions in the 2 sulfates, also we've got very small amounts of the hydroxide ion which is coming from the water. Now, at the positive electrode, electrons are removed, and it's relatively easy to remove an electron from the chloride ion, so that when you've got them present, what happens is the Cl- will go to a chlorine atom plus an electron. Of course, the 2 chlorine atoms will join together to form Cl2, so balance that. So that's what you get in the 2 chlorides. That's in sodium chloride and in copper chloride. Let's see what happens with the 2 sulfates. Now, sulfate ion here is not willing to give away its 2 electrons. And it's easier for the hydroxide ions for them to give away their electrons. So what happens in the 2 sulfate solutions, the OH- that will have an electron removed, and it will actually form oxygen and water, and the electron is removed. Now, to balance that, we need 4 of those OH-, and we're going to produce 1 O2 and 2 H2O, and there's 4 electrons going off there. So that's where the oxygen comes from, that's given off at the anode in the case of the sodium sulfate and the copper sulfate. And interestingly, what's going to happen then, if you keep removing those H+ ions, sorry, OH- ions here, this reaction is going to go forward and it's going to make more hydrogen ions. So H+ ions will accumulate in the solution. Okay, if you want any more explanation on that, on the theory of that, there are a couple of other videos in this playlist, but on this one I just wanted to try and focus on the actual practical, the required practical, where you do those 4 experiments testing what's happening at the electrode of each of those 4 different aqueous solutions.